So good afternoon again. We will start practical session, the fifth practical session of thermodynamics. So this about viscosity, right? Determine the viscosity of the juiced oil. Okay, so viscosity of the thermal fluids too, right? So same procedure, same apparatus, right? So in this session, objective of this session is to determine the viscosity of the juiced oil, and you have to plot the viscosity and the temperature viscosity changes, right? So there are two different type of viscosities as we look in the previous practical. One is right dynamic viscosity, or we can call it as just viscosity or absolute viscosity, right? That is we just talking when we are talking viscosities, that should be dynamic viscosity, right? And kinematic viscosity is viscosity over density. Viscosity divided by the density will be the kinematic viscosity. So there are two type of viscosity we got that. So you can find those two types viscosities, right? I will give you data. So there will be temperature for three different temperature. We are going to give you data, so you can calculate the dynamic viscosity and kinematic viscosity in three different temperatures. So you can plot the graph, temperature versus dynamic viscosity and temperature versus kinematic viscosity, right? So two graphs, and previous practical also you have two graphs, and this practical also same procedure, same discussion also similar, right? You have to plot two graph, right? A dynamic viscosity versus two type of viscosity versus temperature, right? Viscosity will be the x-axis, temperature will be the y-axis, because temperature will be the x-axis because we are changing the temperature, right? And measuring time to collect 50 milliliter that oil, right? In different temperature. So that means we are changing temperature. So that should be x-axis. Y-axis should be dynamic viscosity in one graph. In the second graph, kinematic viscosity, right? You should plot those two graphs similar to previous practical, and you have to discuss the results of the graphs, right? That will be the discussion part. So, and apparatus and everything, everything will be same. So because we are again using redwood viscometer. So this is redwood viscometer, that it will be digital redwood viscometer. So same as similar as I explained last practical. So you should right here you will put you can there are two different places, right? Two only at the same time we can determine the viscosity for two different samples, right? But only we can use one part of this apparatus, right? That means only we are going to use this cup, right? This cylindrical cup. So here we have to fill the sample, and we are heating up this water bath, and we have to heat up the sample up to our requirement temperature. Then we have to collect the sample from the downside using that 50 millimeter, that 50 millimeter cup, right? That will be provide that cup will be provide with this apparatus. So there will be indication for the 50 milliliter level, right? So we can measure, and we have stopwatch. When we start to collect, we have to start the stopwatch, And when the sample is reached 50 milliliter, we have to stop it. And at one temperature, we can measure the time to collect 50 milliliter sample. So likewise, we have to do three different temperatures, right? 60, 70, 80, or 80, 90, 100, or 70, 80, 90, anything, right? So then we will have three different data. So using those data, you can plot the graph, right? And if you know the time to collect 50 millimeter through this that hole, small orifice, that orifice diameter and everything standard, so they will provide equation for these apparatus, right? In the lab sheet, or here you can see that equation. V is equal to kinematic viscosity equal to A into T. The T is the time in second, that time collected taken to collect 50 milliliter through that orifice, right? And B also, they have given that A and B are given that constant, right? And again the small t also same, right? That collected time. So 60 degrees Celsius time is 448 seconds, right? So likewise, this is our observation data. So using those data, you can simply calculate using this the equation. You can calculate the kinematic viscosity, and just by multiply by the density, you will get the dynamic viscosity, right? So likewise, you can get three different kinematic and dynamic viscosity for three different temperatures. Then you can just plot the graph, temperature versus kinematic viscosity. The second one is temperature versus absolute viscosity or dynamic viscosity. So this is what you have to do, same as the previous practical. So in this for this practical, this is our observation data, right? This is our observation data, and we should know that for the calculation, you can see for that used oil, I did three different temperature. I took the temperature as 70 degrees Celsius, 80 degrees Celsius, and 90 degrees Celsius, right? Three different temperatures. So but in the new oil, I did for the 60 degrees Celsius, 70 degrees Celsius, 80 degrees Celsius, right? So any three different temperatures you can take, right? So you can see in the 70 degrees Celsius for the new oil, it took 313 seconds. But in this used oil, 70 degrees Celsius, it took 306 seconds. Right? So what is happening is the used oil take, but same temperature, used oil take less time. Right? In 80 degrees Celsius, 202 seconds. But in new oil, 80 degrees Celsius, 221. Right? For that used oil, 202. So used oil is collected in the same time compared to this new oil. Used oil is collected quickly, right? Why it is? Then that what is the reason is the viscosity difference, right? That will be the difference of the viscosity, right? So we will I will play a video for you, and same calculation table you have to do this one, right? Draw this table and do it, right? And do one calculation for one set of data, right? Just you have equation, then substitute constant values and everything, just you will get, okay? And density I have put here. So used oil 0.85 density is little lower than compared to new oil, right? For the new oil, you can see I have given you what is this No. We take this density as same, right? Okay. Right. Density, we take the density as same, right? But there will be a small difference, right? But we assume density will be the same, right? In every uh, it compared to used oil or new oil, right? In every situation, we assume density will be same, right? But they will be smaller, 0.0 or 0.05 or 0.1, like that, right? It is point zero point sorry, 0.01, 0.02, 0.03, like that, right? There will be a smaller difference, right? We assume we assume that same, right, density. And here we don't need to observe deeply in density, because here we determine and analyze viscosity, no? Therefore we assume those when density will be remain same, because if you consider used oil, there will be a particle, that dirt particle, wearing metal particles, and everything mixed with oil, no? So there will be a small difference in density. Okay, so assume it is same, so you can easily you'll get you can calculate, and you'll get absolute and kinetic viscosity. Then you can pull out two graphs, right? Then we'll go that before look at the discussion part, we will go to the video.
To find out the okay, this is the apparatus to find out the viscosity for the certain lubrication oil. So now we are going to determine the viscosity for the juiced oil. So we have take 50.
You can see by looking this color, you can understand it is used oil, right? Why the color is changing also, that particle, and that yeah, because of the dirt particle and everything, there is a reason for the changing color, right?
Millimeter sample here, you can see up to here it is 50 milliliter. So we take,
here you can see the level, right? This is the 50 milliliter, right?
we took juiced oil 50 milliliter here. So using this and this apparatus, we are going to find out the viscosity for the juiced oil, right? So to find out the viscosity, we have to heat up this sample in different temperature, and we have to measure the time to collect this 50 millimeter 50 milliliter sample. So now we have to fill this sample into this cup. So I am going to pour this sample into this cup. Before that, you can see we have to using this ball valve, we have to close the orifice, right? Under this,
You can see that orifice is that under the spherical part, spherical shape, right? That spherical shape will be matched with this ball, right? That ball valve. Then ball diameter and spherical shape, the spherical diameter will be same. So if you put that ball in the spherical part, the downside of the cup, then it will block that orifice. It will block that hole, right? Then there will be no oil flow through that hole, right? That's how we will block and release this oil flow, right?
This cup, you can see there is a orifice, right? Yes, orifice, right? So when we place this ball valve, it will close the orifice. So now, after closing this orifice, now we are going to fill this, pour this used oil into this cup, right? The sample volume is 50 milliliter, right? So for different temperatures, right, we have to collect this sample under this orifice, right? So while collecting, we have to measure how much time take to this this volume of sample flow through this orifice, right? Okay, now I have to close this cup, and then we will heat up this sample. Let's say we will heat up this sample up to 70 degrees Celsius. Then we will start to collect and measure the time, how much time it take to collect this 50 milliliter sample oil, right?
So this cup is uh, inside this tank, right? Water tank. This is the water tank, right? Then heater will be connected with water. So when we supply the heat, electric current, then heater will be introduce the heat to the water. Then from that water, and there will be a stator, right? Stator will be mix the water, so it will be distributed and heat will flow to the sample, right? Then from the outside we can observe and we can understand and identify the temperature of the water and the sample, right?
Then later, likewise, for the 80 degrees Celsius and 90 degrees Celsius, right? For 3 different temperatures, we will measure the time to collect this volume of used oil, right?
You can hear that sound of the stator, right? The stator will be mix that water all the time, because if that water is not flowing or not moving, then heat may be vary in the different part of the water, right? So we should make sure that every part of the water and the sample should be same temperature, right?
Right now, the temperature is 69. So I'm going to make it as 70 degrees Celsius, right? Then after make the temperature sample temperature up to 70 degrees Celsius, we will start to collect this volume and measure the time how much time it takes to follow, right? When we stop this heater, you can see this valve will be on. That means now heater is off, right? But we continues our tighter, right? Because that water temperature may be vary, right? Therefore we have to mix the water, right? Now
In here, this display, you can say this will display will be indicating that water temperature is 71.0, right? So in here also, in this thermometer also, we can look at the water, right? And there will be small difference. And yeah, so when we reach our temperature, we should rotate this heater, that heater control other side. So we have to stop it, the heater, right? Stop the heater. So then that heat is enough. Then water will we have to mix the water, and water will be flow to this everywhere, and that heat will flow to the sample, water to sample. So now we can see the water temperature is 71, but for the sample, the used oil sample temperature is below 70, right? It is around 60 degrees Celsius. So the reason is we have to give some time to flow the heat from the water to sample.
This is also water temperature, but directly we can measure the water temperature using this thermometer. Here you can see it is around 70 degrees Celsius. The water temperature is 70 degrees Celsius, but here the oil temperature is still 65 degrees Celsius. That means still we have to give some need some time to get the heat from water, right? So we have to give some time so that this sample will get the heat from water, and sample temperature become as 70 degrees Celsius, right? After become the temperature 70 degrees Celsius, we will start to collect the sample. So now we that the sample reach the temperature at around 7 degrees Celsius. So for the 70 degrees Celsius, we start to collect the sample. So we have to place this cup under that orifice.
You can see that
While that water temperature get the heat 60 Celsius, we start to reach the temperature. So, so now we that the sample reach the temperature at around 7 degrees Celsius. So for the 70
now the temperature is around 70 degrees Celsius. So we can assume this is that's 70 degrees Celsius, and we can start to collect the
Celsius,
sample.
we start to collect the sample. So we have to place this cup under that orifice.
You can see this is orifice, right? Above this, that ball valve will be blocking that orifice, right? So when we release the ball valve, that oil will be flowed through the orifice to this cup.
While removing this ball, while removing this ball valve, we have to start the stopwatch, right?
Right. Now you can see this oil is
Right.
flowing, right?
You can see when we remove this ball valve, this sample is flowing through this that orifice, and collected in this cup, right? So up to that 50 milliliter level, we have to wait, and we have to find out the time taken to collect 50 milliliter. So now this limit is reaches to 50 milliliter level, so we have to stop. So this is the time taken to collect 50 milliliter in this 70 degrees Celsius, right?
Right. That time is
After collecting,
in the minute and seconds, but we have to convert it as only second, right? In seconds. So that I have done the convert those time in seconds, and gave it as observation data, right? For I did for this 80 degrees Celsius again, and 90 degrees Celsius again. Then what we have to do is, again we have to take out the sample. Again we have to pour it in the cup. Again we have to block it and pour it, and we have to heat up to next 10 degrees Celsius, that means 80 degrees Celsius. Then again we have to repeat this one, right?
After collected this one, again we have to do this for the 80 degrees Celsius, right? So that we have to again put this pour this sample into that cup, right? Again we have to do it, right? Right. So after collected, we have to again put it this sample into the cup. Then we have to close it and increase this temperature up to 80 degrees Celsius. Then we have to collect again, and while collecting we have to measure the time. Likewise we have to do it for further 90 degrees Celsius. So we will get 3 different readings, right? Using those readings we have to plot the graph, and we can analyze the viscosity varies according to the temperature, right? While temperatures change, when we change the temperature, viscosity also change, right?
So this is this is about our viscosity practical. So this is our data for that used oil, right? Used engine oil, right? 70 degrees Celsius, 306 seconds, 80 degrees Celsius, 202 seconds, 90 degrees Celsius, 112 seconds, right? Took to collect the 50 milliliter sample, right? Through that orifice. So density of used oil, 1.96. I gave this, yeah. Yeah. Okay. You should take density not as same, right? But take it as 0.96, right? That will be 0.1 different changes, right? But I take this from internet, right? There is a we can't tell it is always it will be always higher than the new oil, right? The density of the used oil will be higher than the new oil, but we can't say exactly how much it is that used oil, right? So I took from this from internet. So if you, yeah, it is I think it is better to use this as density, right? Don't take it as again if you assume it is same, that's fine, and there will be no differences in only yeah, it will be constant, no, though there will be no differences, right? Only we are going to draw the temperature and kinematic viscosity, and temperature and absolute viscosity, and we have to compare both, right? But this it will be constant, no? Then there will be no difference, right? So take it as 1.96, okay? 0.96, sorry. 0.96. That okay, because I found it in the internet. I searched and found it in the internet. Average, they assume, we can assume it is it will be always higher than the new oil, but we can say if it is 0.8. Yes, tell me.
One is in waiting room. He say power cut, so he leave.
Who is that?
Ranga Pereira here. I think 70.
Oh, is he where is he attend this here?
He early attend, again he leave automatically. He say he is in waiting room now.
No, there is no way. Wait. No. No, there's no one in the waiting room. Oh, no. There's no waiting room. No, I just send you the link. No, if you click the link, then you don't need to wait in the waiting room.
Okay, sir, I tell to him.
Okay, just use the link which is in your WhatsApp group, right? Use that link and join, and talk. Ask him to talk to me. And then if he has some network problem, and then I will give him a chance. Then he should talk, join, and tell him to join again and talk to me. Okay, then use this density as 0.96. Okay, so it is gram per centimeter cube, right? In the lab sheet, I think they have missed. They have written this unit as gram per second or something. That is wrong, right? That won't be the density's unit. So density unit should be kilogram per meter cube or kilogram per gram per centimeter cube. So here we are going to use density as density in gram per centimeter cube. So because in everywhere we are using centimeter now, therefore it is gram per centimeter cube, and given this equation so line standard, so you don't need to worry about this. This is equation is for the apparatus, right? You don't need to worry about, you don't need to memorize or anything, right? So just use this constant and everything. This concerns about that orifice diameter and everything, right? Those things will be here, right? That A and B, right? So and yeah, that is about of practical. Today's practical, and today this for this practical you have to do yeah, yeah, this is your lab sheet, right? Yeah, right. This is your lab sheet. This is your lab report writing, right? So you don't need to write any theory, right? Because I asked in the first part practical now, so therefore you don't need to write about in theory, right? But theory procedure you don't need to write. You had to just you had to do that what calculation part, right? So the calculation table and do one calculation. Okay, you have to draw the calculation table, and you have to fill those table, and you have to do the calculation for one set of data. For one temperature you have to do and solve it, right? And for others you have to you don't need to repeat the calculation part. Just do one just do calculation for one set of data, and you have to draw that calculation table, and you have to fill the table, complete the table, and you are using yeah using that table. Now you have to plot the graph, so you have to draw the table, and you have to plot two graphs, and you have to discuss the results, right? You have to discuss the results, what is happening when the temperature is changing, right? What is happening to the kinematic and absolute viscosity of the juice oil, right? You have to discuss those things using your graphs, right? So okay, and discuss the characteristics of used oil, used to grommet, right? This will be for the discussion part, right? You have to discuss the, it is not in your lab sheet. So here you have to you can get from internet, sorry, in video, right? Or you can note out now. So this is two part of the discussion question, right? 1 and 2 question and graph and calculation part, right? This will be the lab report for this session. So just characteristics mean what is happening, viscosity and density and everything. Yes, there will be more characteristics for this oil, lubricating oil, right? So those things, what is happening when the oil is using, when we are using oil, what is happening to the characteristics of the oil, right? For discuss the characteristics of the used oil. So and that will be the practical, right? Task for you. So is anyone I think only 21 people. Okay, please put your the index number or race number in your that labs ET something, right? You have to put that number in your chat box. I should take it as that the attendance for this session, and only 21 people here, so I will check. Only 19 people. Okay. 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 Then 20 people. 20 people absent. Sorry, present. So other 7 or 8, 7, I think 7 people will be. I think 7 people will be get 0 if they don't submit in reason or any medicals or any evidence, right? So I think they will have they will have the reason for this for the absence for the absence. So tell them they should contact me, and I already have you that my mail, right? Mail ID. So contact me through that mail. So they should submit the reason, right, for the evidence why they couldn't participate this session, right? So and what is his number? I think some of you told some of you absent in the earlier stage, so present in the earlier stage. What is his number? I think one of you, yeah, then 96. Okay. Okay, then 21. So if you have any clarification regarding this session, please ask me. So this is just about determining the viscosity of the used oil, and we are done last week we have done for the new oil. So then outcome of this practical is to understand what is viscosity, why we use viscosity, one device for us. One device for us. What what he is asking? I don't not understand. 096. What you asking? Zero 96. 096. Are you there? So okay, if you have any doubt, please at least put your comments or put your question in that chat box, right? So our practical outcome is about understanding and determining the viscosity, right? And after this session, you have to know about these viscosities and how these viscosities differ from oil to oil or oil to different fuels, right? So or how it will change according to the temperature of the specimen or sample, right? So because oil, we are using oil in different engines and different parts, which which temperature can be changed, right? Then those lubricant oil will be should go through different temperatures. So then when the temperature is changing, there will be changes in viscosity. So that will affect the characteristic of the lubricant, right? Or that yeah, the purpose of lubricant, right? So so that we have to determine, we have to understand how this viscosity changing changing with the temperature, right? And what are the types of viscosities, right? Dynamic and kinematic viscosity. What is viscosity? Those kind of viscosities. And yeah, and you all understood about how we can determine the viscosity, right? It is just when we just let it flow to the orifice, right? Then we are just collecting and measuring time to collect some amount of oil, right? The sample, it is 50 milliliter. Then we by using that we are calculating that viscosity. So that is how collecting the oil. And you can see but same orifice diameter and the whole diameter is the same, but when the temperature increasing, you can see that the time taken to collect 50 milliliter will be decreasing, right? That reason is that viscosity is when the time is when the temperature is increasing, viscosity will become low, right? So the viscosity is decreasing. Therefore, that the flow rate in that same hole, in that same orifice, is increasing. right? So wait a minute. Okay, sorry, I get call from my lecturer. So this is about our practical. So from out of these two practical, two part of this practical, you should be able to understand this thing, right? So how the viscosity is changing and how important the viscosity is. Then simply you can see when the oil is why we use why we throw down used oil, right? Then because there will be the viscosity is lost, right? The new oil, when the new oil lost the viscosity, we just throw down it, right? We can't use for anything, right? Because that viscosity is the property that we need when we use those oil as lubricant, right? So the lubricant content is depend on the viscosity. So that how important the viscosity is. So these are some something about viscosities, and if you are doing practical physically, then you will get more. I think unfortunately we couldn't do this. So we are conducting here through this Zoom. But when you back this back faculty, so if you wish, if you make schedule, if you have time, then we can go and observe, and we can you can just observe those operators, and I can explain what we have done, what we have record our practical, right? Then physically you will yeah, get more many thing out of this practical, right? But somehow as we are doing virtually, uh, it is our maximum. I did my best, I think. So at least you should get something, right, from this practical session. So simply when that yeah, when the flow rate is increasing, the same hole, right, same size orifice, that means the viscosity is decreasing, right? When the flow rate is increasing, that the time taken to collect a 50 milliliter will be decreasing. That is happening, right? So simply we can understand those things, right? So as you can see here in our data also, when the temperature is increasing, here you can see the time is decreasing. Why it is decreasing? The flow rate is increasing, therefore time is decreasing. Why the flow rate is increasing with the same size of hole? Because when the temperature is increasing, the viscosity is decreasing. When the viscosity decreasing, then there will be the resistance to flow will be decreased. Therefore, the flow will be flow very fast, right? Then the time will be less. The less time will be need to collect the same 50 millimeter sample, right? That is happening. So that is out of this practical. I think I will give you for 10 minutes to discuss and about this practical session. So after discussion, 10 minutes or 15 minutes, you can take and discuss with me, and after that we can wind up this session, right? Same as every practical, you have 1 week to submit. So please don't submit delay, and submit with the due date. And please, when you are submitting, please make set after taking your photos, or after make it as PDF file, you can see, right? Please look again. Some of you submitted very clearly, right? When we are correcting, we are read, no, but I think some of you don't. The writing is very bad, and don't cut it out, right? If you want to cut it out, then rewrite it. That should not be the report, right? Just cut it out and doing no, not like that, right? You can keep the cut it part, and cut it words or anything in that report, right? That should not be that yeah, that is not the way to write or submit the lab report, right? I don't know, some of you, yeah, many of you, I think, yeah, many of you have done that thing, right? I think you have a lot of time. 1 week, you have a lot of time. I think you can write. And some of you write it as points form. Very good, because it is easy to read and easy to understand your points form, and okay, then easy to give marks for you, right? So that's fine. In every question you can write as it has points form. It is difficult. It doesn't matter. But other thing is, most of you, yeah, I think half of you wrote some sketch, and yeah, that is very good move, right? Sketch and everything. That is the way to write report, right? Just writing thing is just that is not that always not indicate your involvement, right? Do you understand? I think you will understand those things. So I just always looking what is your involvement in the lab report. That is depend on your involvement in practical session. If you don't involve here, you can write, right? Just you can copy only. You can write anything. I think you are not going to play any again play and see this video. I think you are not going to do that. But I think that absence people also never do like that. I never going to play and play the YouTube, play this video and play. I don't think. If you are in doubt, sometimes you can play, but those people, I think, just copy your lab reports, right? So that is we can't give marks for that. That is, there will be no outcome. Then there's no outcome. Then no point to give marks for that. Then that will affect your future, right? So that is my concern. So okay, I'll give some time. Please ask me if you have any questions. If you can ask anything, right? Regarding any report submission or anything, right? Any doubt, if you have any doubt, you can ask. This is the time for that, right? I think only 2 people submitted their report, that medical, right? And if you don't, if you had really any problem regarding attending this practical, and if you do not respond and do not talk to me, or if we couldn't get response from those people, then we can't do anything, right? Then after submitting your lab practical marks, then you are coming and talk to me is very that late proposal is very bad. And after some time subject report marks to your module coordinators, we can't change marks. So those things you have to consider. And within 2 days, I told you that